it says the switch is now moved to position Y. Show that the time constant for discharge is this. Now, if it had like time constant discharge, fine. Time constant is basically the product of resistance and the capacitance. By the way, I just want to tell you. If I could actually understand from this whole question, I don't see there is a capacitor. We know the capacitance of this, right? Interesting. If we don't have the capacitance, then we can use V is equal to V naught E minus T upon RC. We still have no capacitance, but this is the time constant we can find. Actually, we can find time constant from this. We can know, but we don't have the time constant. I'm not happy with it. So we can find capacitance, right? Q is equal to CV. And then we don't have the charge. Let me think about it for a second. So we have the resistance right here, and we don't have the time constant, which is not good. We want time constant.
Sir, हम लोग Q equals CV लगा के निकाल नहीं सकते capacitance?
Q नहीं है ना? Q हमने कहीं निकाला था?
है तो 1.2
वो ग्राफ से है ना सर?
You're right. This is simple then. 1.2 times 10 raised to power minus 4 था. And C, and this is 8. So what is the capacitance then? ये आप दोनों पहले क्यों नहीं मुझे बताया? Okay. The capacitance is
1.5 10 raised to power minus 5.
1.5 10 raised to minus 5 farad. What you do then? Resistance is 220 kilo, I think. Kilo ohms. 10 raised to power 3. So what you get?
3.3.
3.3.
3.3. Yay! Proved. Now the fully charged capacitor in E. Determine the time taken for the energy stored decrease from this to this. Okay, now this is pretty easy. So time taken for energy to decrease from this to this. Okay. Very, very nice. Let me think about it. So V equals to V naught E minus T over RC. We have the time constant. We have the time. Oh, no, we don't have the time. You have to find it. We don't have these two. Good. But we have energy. So energy was half into Q times P.
Sir, हमारे पास V naught नहीं है?
V naught नहीं है हमारे पास.
वो जो 8 है वो V naught नहीं होगी सर?
नहीं.
सर हम V को V naught by 3 से replace करके फिर V naught cancel कर सकते हैं.
हाँ कर सकते हैं. I'm just looking at what is the relationship between V and so QV होता है ना half into QV. So relationship इसका मतलब ये हुआ कि E and V are directly proportional. If they're directly proportional, this means डायरेक्टली प्रोपोर्शनल नहीं है क्योंकि चार्ज तो चेंज होगा. चार्ज नहीं ले सकते हम CV स्क्वायर से चेक कर सकते हैं. उसको कैपेसिटेंस विल स्टे. सो E इज डायरेक्टली प्रोपोर्शनल टू V स्क्वायर बिकॉज़ Q भी चेंज होता है ना इसमें. नाउ इसका ये मतलब हुआ that if energy is E and voltage is, if energy was E naught and voltage was V naught, so when energy was done by like 9 times reduced, so how much times would it be reduced? 3 times. You know why?
Under root है ना सर?
Under root है ना, so that's why. B over 3 करेंगे और square करेंगे 9 आ जाएगा ना इस तरफ, so that's why. Okay, so if you don't get it, like you don't understand how I've done it, so I'll tell you again. Energy is half CV square. I can write it as E1 equals to V1 whole square like this, right? So I can make it proportionality over E2 over v2 whole square like that. ठीक है, अब पहले हमने कह दिया ये E था और हमने ये क्या था, बेसिकली E/9. सो हम ढूंढना चाह रहे हैं कि अगर ये V था तो ये V2 कितना स्क्वायर है. ठीक है, सो ये कैंसिल हो गया, 9 ऊपर चला गया, सो ये 9 है. अच्छा, आप क्या करेंगे, V2 स्क्वायर हमने फाइंड करना है, V2 फाइंड करना है. सो V/9 आ जाएगा, अंडर रूट लोगे इस तरह. सो V2 किसके बराबर आ गया, V/3 के. So you can always, make a ratio like that as well. Anyway, so it means this will be V/3, this will be V0, and this will be E minus T over RC. This and this cancels, 1/3, and ln 1/3 minus T over RC. अच्छा, अब यहाँ लिख सकते हैं -ln3 equals to -t, और टाइम कांस्टेंट हमने निकाला था 3.33. So ln3 times 3.33 is
0.6.
sorry
3.6.
3.6 seconds. Yay. Okay. Now, second identical capacitor is connected in parallel with the first capacitor. State and explain change any to the time constant discharge. Parallel में capacitance बढ़ जाती है.
तो इंक्रीज होगा.
हाँ, सेम टाइप है तो capacitance is now 2 times. So time constant is dependent on R and C, hence T increases. ठीक है, is it clear? Pretty easy. Now go to question number 6. All right, so compare the magnetic flux of two solenoids. So there is turns of 3,600. Okay, so definitely compare the magnetic flux of two smaller cross section area placed. Okay, there is no current or there is current. Flux, compare the magnetic flux. Largest solenoid 600 attached to DC power. Okay. Okay. So it means कि अगर magnetic flux generate इसका हुआ तो इसका कम होगा ना. So it will be smaller. It will be smaller in small coil. This is because उसको कम मिलेगा ना वैसे, क्योंकि ये कम मैग्नेटिक, इसकी मैग्नेटिक फील्ड लेस स्ट्रांग होगी और इसको अट्रैक्ट करेगी, सो इस बेचारे के साथ जाती है. दैट्स नॉट गुड. नाउ कंपेयर द मैग्नेटिक फ्लक्स लिंकेज. लिंकेज के केस के अंदर डेफिनेटली द ग्रेटर द टर्न्स आर द लिंकेज इज ग्रेटर, राइट, बिकॉज यहाँ पे हम बात करें फाई एन की, which is VAN. So greater number of turns is smaller, so greater linkage. Okay. Now it says state the Lenz law. This is the first time he has asked it. Wow, Faraday Boshta. So the Lenz law is that the direction of induced current, you can also write here, direction of induced current is such that to oppose the change that is causing it. So if you have forgotten about it, please check the notes. I'm clearly recovered. The terminals of the smaller solenoids are connected together. The smaller solenoid is then removed from inside the large. The terminals of smaller solenoid connected together. The smaller solenoid is removed from this. With reference magnetic field, explain why force is needed to remove. Okay. अब वो लेंस लॉ की वजह से हमने पहले लिख लिया, ठीक है. Number 1, change in magnetic flux linkage. ठीक है. causes EMF to be induced in smaller coil. All right. Now, the induced current has its own magnetic field in the opposite direction. How do we know this is the opposite direction? Because I told you, because of the Lenz law, as you can see. Okay. Hence, two fields interact to attract each other. That's why. 3 marks, 3 points. Please do remember this. If you have made a mistake here, give us a mistake on each piece. Anyway, question number 7. So this is pretty simple. अच्छा इसका एक ट्रिक भी है. ट्रिक ये वाला जो होगा ना, अगर ये दो ऐसे दे दिए तो ये हमेशा इसके पैरेलल वाला होगा, यानी like this. और ये इसके पैरेलल होगा, यानी so that's something very easily you can always draw this. उसके बाद कहते हैं mark positive for the output. So for this I would recommend that you should go take some color pencils just for your own, don't write anything with color. You have to write in black or blue pen. So you start from this, you go here, you can't go here, you go here. Okay, well, output is, sorry. You go here and just try to complete it. See if you can. Yes. So this would be the positive side. I know this, but for your own reference, you can use another color. Make this positive. Go here. Because you can only go here, go here, then here. You can only go here and then here. So this would be the positive, this would be the negative. So you can then, erase all this. You don't have, oh, I also erased that. Erase this, you don't need it anymore. And just mark where the positive is. Now, determine the equation of V in terms of V in volts and time t. अच्छा इसके अंदर, because this is a sinusoidal wave, so V equals to V naught E, sorry, sine theta. Okay, so first I'm going to write it like this. Okay, then what you want to do is sine theta में हम डाल देंगे sine omega t, because this is a circular motion sort of thing. अब उसने कहा V की इक्वेशन लिखो in terms, right? अब ओमेगा भी ढूंढना पड़ेगा in terms of V volts and T. Omega is 2 pi by T, which is I don't know what this is. Who's going to tell me? इसको ऐसा करते हैं ना, ये it's very ambiguous. नहीं, ये बहुत ambiguous. जैसे 2.5 बन रहा है, so 2.5 ले लेते हैं. ठीक है, so 2 pi over 2.5. Okay, so pi को ना हटाना, 2 और 2.5 कितना हो जाएगा? हटा भी तो क्या फर्क पड़ता है? 2 over 2.5 is 0.8. 0.8 pi. Okay, so we can write V naught sine 0.8 pi t. Okay. I don't think so we can do more than this. However, yes, we can. We have to remove V naught as well. So ये V naught का top value है. So this is 3, 3.2, 3.4, 3.6, 3.5. Sine. चलो होगी. और कोई वेरिएबल बचा नहीं है ना? उसने कहा था V और V होता चाहिए. Done. Yes.
सर 2 पाई over 2.5 2.5 ही होता है
2 पाई 2 over 2 पाई आपने इस पूरे को 2.5 ले लिया होगा ऐसे
जी
हाँ वो भी सही है मैंने पाई की टर्म्स में लिख दिया ना
अच्छा
जी okay then says the supply is connected to 12 volts resistor calculate the mean power dissipated in the resistor acha for this one power is equal to VRMS square over R right so ये हम power average देख रहे हैं अच्छा अब RMS जो है वो तो हमारे पास है नहीं this is a problem तो हम इससे करें क्यों हम ऐसे नहीं कर सकते V naught over under root is VR तो करो ना मीन पावर निकालनी है पावर मीन should be equal to peak power divided by 2 so peak power is V square over R don't you think so ऐसे होता ना so ये आ जाएगा V square over 2R V square कितना था 3.5 square over 2 और 12 ये आसान निकालो आंसर क्या I think it should be 144
0.51
0.51 watt that is correct if you guys have any questions please let me know अच्छा इसके और भी तरीके हो सकते थे that you first calculate you know VRMS और peak power ये वाला फॉर्मूला भी आप लगा सकते हैं अगर आपका दिल करे VRMS square over R that would also give you the same answer it doesn't really matter okay then state the formula for de Broglie state any symbol you use so de Broglie is this H over D and then you have to explain this how this is Planck constant and this is momentum of particle okay then you have the screen okay state the name of phenomena shown by electron diffraction state what is this phenomena shows about the nature of electrons that moving nature of electrons moving electrons can also can behave as waves okay so that any particle moving will by the says why the thin crystal causes the phenomena the spacing between molecules or atoms if equal to wavelength of electrons maximum diffraction is going to occur ये AS की चीज है so you should know now going to this one state explain the change that has been made to potential difference to create the pattern the electron is accelerated to different potential different new pattern पहला कौन सा था okay lines are closer if the line is closer this means that let me think about it line is closer so lambda should be less if the lambda is less then according to our equation momentum should be more right momentum is equal to mv how could we increase our mass is constant we should increase voltage and to increase the voltage the only reason is we should increase the potential okay so I'm going to write it down increase the potential energy supplied because that is E equals to VQ. So increase V. Hence, velocity will increase as kinetic energy increases. Okay. So lambda decreases. Yay. All right. Now question number 9. Complete the equation for this decay. Alpha निकाला है 4 211 minus 4 is 207. 84 minus 2, 82. Determine the decay constant of polonium. Give a unit to your answer. अब decay constant कैसे हम निकालेंगे? Good question. Do we have half-life? We don't. So we can find half-life. 24 to 12. Go here. Go here. And that's your half-life. So that I think is 0.52. 0.52 आ रही है ना?
जी.
So lambda equals to ln2 over 0.52. And the answer is ये भी किसी ने नहीं किया हुआ. That's not fair. ये तुम लोग
1.33 आ रहा है.
1.33 और seconds -1 होगा क्योंकि ये second में. Okay, then it says use your answer to calculate the activity at time 0 of the sample of polonium. ये कैसा सवाल है भाई? एक्टिविटी निकालनी है. वो उधर क्या गिवन था? एक्टिविटी नहीं, n था. तो 24 ये आ गया लैम्डा n क्या निकला था? 1.33 times n क्या था? 24 times 10 raised to 12. Yes, what is the activity?
सर उसमें क्या है? टाइम 0. तो टाइम 0
तो proof ये टाइम 0 पे क्या है? and 24 times 10 raised to 12.
अच्छा.
Answer please.
So 3.1 times 10 is power 13.
Very good. Okay. Then on sketch a line to show variation of T lead nuclei in this sample. अब हमें कैसे पता चलेगा ये कि lead के बारे में इसने कुछ कभी बताया था इसने? अच्छा, it decays lead. Oh, so lead as the lead is going to be there, I think more and more particles are going to be there. My assessment of this. So let me think. So it will increase with the same. So we have to make sort of a mirror image. Okay. So lead will definitely start from 0 and no lead was there. And then we have to find the point where both of them is going to be same. And I think that it should be the same. एक तो हाफ लाइफ वाला जो है ना उस पार्ट पे तो हो गई. हाफ लाइफ का मतलब ये है कि हाफ अगर पोलोनियम हुआ है तो एग्जैक्ट हाफ इंक्रीज होगा लेड में, like this. Okay. And when it is like 24 minus 24, what is this? Sorry, let me check. ये कितना आता है? 4.2 4.4 नहीं, ऐसे नहीं. 4.4 4.8 5.2 आता है ना. तो 22 से वो 5.2 पे गया है, तो ये मतलब उतना चला जाएगा. अगर हम 24 को 5.2 से माइनस करें, यानी हाँ, तो कितना बनेगा वो?
18.8 बनता है.
18.8 बनता है ना. तो 18.8 तक ही चला जाएगा. Where is 18.8? 18 is here. 18.4.8. So the line will go like this, smooth curve like this. अभी मेरी line बहुत गंदी है, but I will try to make as smooth as this. Okay, like this. So it will be like this. Exact mirror image banana. Okay. Is it clear, everybody? All right. Now, each decay releases an alpha particle with energy this. Calculate in joules the total amount of energy given to alpha particles that were emitted between T3 to T9. So we are going to check how many particles decayed. So it's 16th, and here it was 6.4, 6.8, 7.2. So how many particles actually decayed here? 16 minus 7.2. Can you do this, please?
Or
8.8.
8.8 times 10 raised to 12 particles must have been released of alpha. Okay. So अब हम लिखेंगे 8.8 times 10 raised to 12 particles, और हर particle की energy है this much, and kilo है so 10 raised to 3, and EV 1.6 times 10 raised to minus 19. Okay, can you do this?
फॉर्मूला कौन सा यूज किया आपने इधर?
कुछ भी नहीं किया. K EV को change किया. K means 10 raised to 3, और जो है क्या कहते हैं, and EV is this.
Answer 9.7.
9.7 joules total निकलेगी. Okay, do you guys understand? Like that. Okay, suggest why total amount of energy released in decay process is greater than your answer. Okay, so दो इसके हो सकते हैं. Products have kinetic energy, and gamma was released. So ये याद कर लो, every time this is the same thing. Okay. Then question number 10. X-ray tube accelerated through potential difference 75. The electrons strike a tungsten target, effective mass 15. Okay. Okay. The electron energy is converted into photons, efficiency 5%. The rest of the energy is converted thermal. The X-ray tube produces image using the current of this. Okay. The heat capacity is this, determines the temperature change. Wow. So Q equals to MC delta T. अब हमें निकालना पड़ेगा कितनी एनर्जी आई है. We have the time, we have the current. So what you do? Energy will be equal to V, I, and T. Potential दिया हुआ है कि नहीं दिया हुआ? I don't think so there is any potential, right?
Yeah, 75 kilovolts.
Ah, yes. 75,000 times 0.40 times 20 times 10 raised to minus 3. ये आ गई एनर्जी टोटल थी. अच्छा, इसकी ना ओनली 0.95 से मल्टीप्लाई करने का पड़ेगा. द रीजन इज कि 5% तो फोटोन में चलेगी, तो बाकी हीट में जाएगी, है ना. सो देन mass is 15 grams, ये kg में. So 0.015, 1000 डिवाइड करना, times 130 times delta T. So what is the answer?
So 290.
290 kelvins. Okay. Then the linear attenuation coefficient of X-ray photons muscle is 0.22. Calculate the thickness of the muscle. ये तो आसान है. I equals to I naught E minus mu and X. अच्छा, अब x हमने निकालना है. The linear attenuation is given. Calculate the thickness. Do we have I over I naught? Do we have that? I think so we have, right? Only 5% efficiency given है. X-ray tube produces this tungsten. The attenuation is this. Oh, sorry. The other
So
calculation
20%.
of T. 80% absorb हो गया, right? So 20% होगा. 20%. So 0.20 I naught. So I naught and I naught cancel. And ln 0.20. This will be equal to minus mu x, and x will be minus 0.22. What is the answer?
7.3.
7.3. Okay. Okay. Then 2 X-rays images are taken. One of them equal thickness bone muscle and another equal thicknesses of blood and muscle. Actually, one of these images has good contrast, but other does not. Yes, of course it doesn't. Right. So if you can see that bone has a large difference in absorption coefficient with other two. So better contrast. And small difference between blood and muscle means poor contrast, as they both have almost same observation. Okay, that's not bad. Easy. PET का question भी आया. So what is meant by tracer? हर दफा यही पूछता है. That's not good. So tracer is a substance containing chlorine 18 नहीं लिखना. मतलब tracer किसके भी हो सकता है? That containing radioactive nuclei that is introduced into the body. That's what the tracer is. PET involves annihilation. What is meant by annihilation? Annihilation का मतलब complete destruction. Okay. So when a particle meets with its antiparticle. So their mass is converted to equivalent energy. That's what annihilation means. State the name of the particle involved in annihilation process. इसमें हमेशा electron and positron. Do not write anti-electron. There is nothing as anti-electron. Okay. Positron. Calculate the total energy released in one annihilation. बड़ा आसान. So E is equal to mc square. So there are two masses, see? So 2 times 9.11 times 10 raised to minus 31. The mass same. Okay, what is the answer?
1.64 times 10 to the power negative 13.
Okay, cool.
सर ट्वाइस क्यों किया?
दो है ना, एक इलेक्ट्रॉन एक प्रोटॉन पॉजिट्रॉन,
अच्छा
दोनों का मैस कन्वर्ट होगा, एक का मैस नहीं कन्वर्ट होगा. अब वेवलेंथ कैसे निकालेंगे? वेवलेंथ ऑफ दिस विल बी h और p से तो निकाल नहीं सकते, hc और लैम्डा से. अच्छा, अब प्रॉब्लम पता है इधर क्या है? प्रॉब्लम ये है कि जो हमने एनर्जी निकाली है ये दोनों के एनाइलेशन, और आपको शायद मालूम हो और शायद ना मालूम हो कि when electron positron pair is annihilated, right? So two gamma rays are released, photons are released, and they always go in the opposite direction. So यहाँ दो होना चाहिए, इसका मतलब है दो निकलेंगे इधर. So हमें एनर्जी को हाफ करना पड़ेगा. Okay, energy by 2. Yes, multiply करते थे. Okay, 2 times 6.63 times 10 raised to minus 34 and 3.0 times 10 raised to 8. 1.64 times 10 raised to minus 13. Okay, and the answer is
2.43 times 10 to the power negative 12.
okay, very good. Now, then say explain how the gamma photons are used to produce an image. अब ये मैंने तुम लोगों को लिखवाया था, ये आखिरी वाले सेक्शन में आप जाएंगे, मैं लिखा हुआ. So what you do in this annihilation, 2 gamma photons are released 180 degree from each other. That's one point. Okay. The second point, you have to write 3 minimum. Gamma are then detected by series of ring detectors. Third, the location of production of gamma is determined, fourth, by computing the difference in time of arrival of both gamma photons. So that should be the answer. Okay, is it clear?
सर आपने सेकंड पॉइंट क्या लिखा है डिटेक्टेड बाय के बाद?
Gamma are detected by series of ring detectors. ठीक है, ये लिखा हुआ है ऑलरेडी, नोट्स में जाओ, ये पूरा लिखा हुआ है, 6 मार्क के लिए मैंने लिखा हुआ है. इसके बाद ये है कि आप लोकेशन इज प्रिसाइजली टेकन इन, एंड फिर लिखा हुआ है कि द पॉइंट वेयर द मोस्ट gamma particles are being detected or located, that means that the tracer has a greater concentration, which means that there is an abnormality, or उसको multiply कर रहे हैं, something like that, right? So you have to write it like this. Okay, oopsie. All right, let's go. The last question. Wow, luminosity is the total power radiated by the star. Okay. Now luminosity given है, distance of the sun be given है, calculate radiant flux intensity. Radiant flux intensity is the luminosity over 4 pi d square. Okay, 3.83, 4 pi, and d would be 1.51 times 10 raised to 11 whole square. What is the answer?
1340.
Yeah, 1340. This is watts and niche meter square. Watts per meter square. Use data from B to calculate the mass that is converted into energy every second by the sun. Not that hard. E is equal to mc square. So we want to find mass. Energy is, how do you know the energy? That is the power, each second है ना, power into time, 1 second, divided by, नहीं ऐसे तो नहीं होना, ये energy आ गई, equals to mass times 3.0 times 10 raised to 8. Okay, can you do it? Answer?
4.26 times 10 power 9.
9 kgs. Wow. The radius sun is this. Show that the average temperature. अब आपको Wien's constant. Wien's constant से ही निकलेगा ये. Wien constant के लिए तो आपको peak दी नहीं है. फिर ये कैसे निकलेगा? Stephen Boltzmann से निकल सकता है. I think. Stephen Boltzmann से निकल सकता है. Show the temperature. Show the temperature is this. Okay. Stephen Boltzmann constant is 4 pi constant r square t4. Radius square हो गया ना? ठीक है, अभी कर लेते हैं. 4 pi r square. Okay. So सही है. Luminosity थी 3.83. 4 pi. ये जो है 5.67 times 10 raised to -8. Radius था 6.96 times 10 raised to 8 whole square times t raised to power. So क्या आंसर है? ये आंसर है. Okay, proved. This is pretty simple. अब आ जाओ इधर. The wavelength of light for maximum rate of emission occurs at the sun. Okay, the temperature of surface of Sirius is this. Use information to determine the wavelength of light for which the maximum rate of emission occurs from Sirius. बड़ा आसान है. Wien's constant इधर लगेगा. Wien's constant is lambda max times t equals to constant. यानी Wien's constant. So we can say lambda 1 t1 equals to lambda t2 times t2 like this. अब पहली उसने wavelength sun की दे दी है. That is 5.0 times 10 raised to -7. Temperature sun का भी हमने निकाला है 577. अच्छा, lambda 2 हमने निकालना है और temperature क्या है 9940. So lambda 2 is so easy. This is. Yes. Answer. Hello. Lisa की लाइट से नहीं चलेगी. Okay.
So 2.9 times 10 is power 7.
Lisa, are you here? Okay.
Yes, sir.
Thank God.
And positive 7.
Positive 7. Okay. So positive 7 नहीं आ सकती.
नहीं सर, नेगेटिव है.
ये जब negative 7 है वो कैसे आ गया?
This is positive 7. Negative.
Okay. So आपका हो गया यही पेपर खत्म. तुम तो कहते बड़ा मुश्किल पेपर बसाम, मिस्टर बसाम, ये तो मुश्किल पेपर नहीं है।
बीच में मुश्किल सवाल थे ये इंडक्शन वाले और एक्सरे वाले।
कोई एक्सरे में मुश्किल कुछ भी नहीं था, ये तो बहुत आसान सवाल है। सिर्फ एक क्वेश्चन अच्छा था जिसमें वो हाफ लाइफ वाला, उसके अलावा तो कोई सवाल ही नहीं था इसके अंदर।
क्या वो लेंस लॉ वाला भी तो मुश्किल था?
लेंस वाला कोई मुश्किल नहीं था, सिंपल था बिल्कुल, पढ़ा तुमने सब कुछ। ओके, सो हु स्कोर्ड व्हाट, टेल मी। असल में अब रोजा तुम लोग रखा हो, झूठ ना बोलना। लीजा, यू कैन स्टॉप द रिकॉर्डिंग, ये ना आपके फिर यूट्यूब पे जा रहे हो मार्क्स।